Hello class, welcome to 6.1A Systems of Equations. When we talk about systems of equations, what we're really looking for is where are these two different lines going to intersect. So when we look with linear equations specifically, what we are looking at is, finding one of three solutions. In the first case, you can see here that these two lines, if graphed, are going to intersect at this one spot in the middle. Now, we could look a little closer, and we could pretty much determine that is going to be a 1, 4. Okay? Not every solution is going to intersect so nicely like that. The other situation we might be looking for is two equations, and we recognize that they have the same slope. So if they are looking at the same slope, they're going to be parallel and not intersect at all. So that will get us a no solution. And the last case is infinite solutions. Well, what do we notice about this? If we even look at this y equals 9 divided by 3, well, that really is like 3x plus 1, just not simplified. So they are the same line. So if you look on this graph, every single point would end up being an answer. So this would be like an all reals or infinite solution. Now, I will say one solution is going to be the most popular one. They should typically intersect somewhere. And throughout this week and throughout this lesson, we're going to talk about a couple different ways. But today we're going to specifically talk about graphing. So let's take a look at a few examples. Example 1, systems by graphing. Now, so when we look at these problems and we start graphing, and even if we try to hand graph, we can see pretty clearly that the solution is going to be right here, or the solution is going to be right here. So, but the problem is that's some decimal answer, some fraction answer, and we don't really have a good answer for that, not like the example above where it was pretty clear to see where they intersect. So we really don't want to waste our time like hand graphing these, but what we will want to use is use the graphing calculator. So the steps of that is the first thing when you're going to need to make sure is it's going to be in y equals mx plus b. Okay, it's going to be important that we remember how to convert them back to y equals mx plus b if they are not given to us in that form. So in the y equals on your calculator, there's going to be a y1 and y2 that we're going to use. We always want to make sure our zoom fits so we can see what's going on there. And then 4 is going to be the important step. We are going to make sure we hit that second calc, and that's going to end up be our intersect key. Now, what you're going to have to do is hit enter, enter, enter through the first curve, second curve, guess. And what that's going to do is give us an answer. An alternate option is we may be able to find them in the table, but we'll take a look at that probably in class. So let's see if we can take a look at how to do this. Okay, so the first thing we're going to want to do is we're going to need to make sure we get these equations into our calculator, which starts by hitting this y equals button. Once we're in the y equals, we're going to go through our 1/3, our x plus 1, and this is where we need to use y2 to also say y equals x plus 2. Once we get to here, this is where we could click on that graph button to see where it's going to go. So that looks a lot like what we're seeing in our problem, but that's not going to help us find the answer. That's going to be when we hit the second calc button. Now we want to go down here to the number 5, or hit 5, and then this is where we hit enter, 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 and it's going to take us to our answer. So this is where we want to make sure we stop and create our answer, or take our answer. So as you can see in our calculator, this negative 1.5, that is going to be our intersection point of that first example. Okay, let's take a look at the second one. If we have to take a minute to play back these videos, we can. All right, so for the second one, we need to start by writing in our new equation. So I'm just going to overwrite them, negative 3/4 x, okay, plus 1. Then we're going to go back and we're going to do our 1/4 x plus 2. You can always clear them out first if we want to. But make sure we get these new equations into our calculator. Once you hit graph, we're going to be able to see that they intersect down here. But again, it's not at a clear point, and we don't want to just assume that was at a good point. So we're going to hit the second calc, and it's going to bring us to this menu. And we're going to want to hit the 5 button, because we want to find out where these two lines intersect. Now it's going to hit a first curve, enter, second curve, enter, guess, enter, and this is where we want to pause to write our answer. We can see here that our x value is 3, our y value is negative 1.25. So our intersection point is 3, negative 1.25. Now, if we look over here at our answer, oh, that looks pretty clear that that's a 3 there. Now here, we know it's not directly on the negative 1, so yep, negative 1.25 looks pretty good. And that's how we're going to want to address our systems if they are in the y equals negative 3/4x plus 1. So again, our slope-intercept form. So let's take a look at example 2, and how are we going to address that? Well, in example 2, the first thing you should be recognizing is both of these equations are not in y equals mx plus b form. But we should be able to solve for them. So the first thing we're looking at is subtracting 2x from both sides, solving for y, and now we have y equals negative 2x plus 4. That's going to be something we can plug in the calculator. Subtract 2x, subtract 2x. We're left with negative 3y equals negative 2x plus 6. And then we're going to divide by negative 3. Now remember, we're dividing this whole thing by negative 3. So that is going to simplify to 2/3 x minus 2. Because negative 2 divided by negative 3 becomes a positive. 6 divided by negative 3 becomes negative 2. So now we can take a look at these answers. And we should kind of see that when we graph these, or if we tried to hand graph these are not going to intersect at a good point. So now's a good time to let's get our calculators out and plug these two equations in so we can solve. So when we look at our calculator, first thing is we can clear out those equations, make room to plug our new ones in. So again, we're just kind of hitting those negative 2x plus 4. We're going to plug in our 2/3 x minus 2. Again, remembering to plug your x in, and this is all in this y equals. Okay. Once we get our equations in, we can take a quick peek at the graph. And it's kind of hard to see what that might be. So we're going to hit the second calc. And we want to go down to 5, whether you scroll down or hit the 5. And that's going to take us to that first curve, second curve, enter. And now we want to pause so we can get our answer. And it's going to come up right down here with our intersection point at 2.25, negative 0.5, which we can see the 2.25, that sounds reasonable. Down a half, that looks pretty good. So our answer here would be 2.25 as our x, negative 0.5 as our y value. Okay, and that's it. Example 3, check a solution. Now, one thing we should be able to do with these, and we have some options here, but this is a question that they really like to throw onto your Keystone test. But they're trying to ask us, determine if 1, 1 is a solution to the given system. So if we are asking, this is really going to be saying, do these two equations intersect at 1, 1? Well, if they intersect at 1, 1, what we should be able to do is plug in 1 to both of these, and what we should end up finding out happens here is 4 equals 4. So that's good for the first one. But we also want to plug 1, 1 into the other one to say, does 3 times 1 minus 2? So now we have 3 minus 2. Does 1 equal 1? If the answer is true for both of them, yes, this is a solution. Yes, it is a solution. So it's going to be very much like what we were doing when we were doing our test points for our inequalities. But we want to make sure that this point is going to be a solution because just trying to draw a quick sketch, who knows what it actually looks like. But if both of these check off, that means that point 1, 1 is going to be where they intersect. So the same thing is going to apply over here if we're trying to test out negative 2, 6. Now, a little bit harder to do, but let's just do that first one. Negative 8 times negative 2 plus 2 times negative 6, and that's going to equal 4. So take your time to kind of check these out, or if you're just using your calculator, but that's going to be 16 minus 12. Does 4 equal 4? So that one's good. If we plug in negative 2 minus 6 equals negative 3. So negative 8 equals negative 3. Well, that one's no good. So this would be a no, not a solution. Because what that's going to essentially tell us here is something along the lines of when we get these two values, one of them is going to be up here, one of them is going to be down here, or maybe not even on the same value. So what we're looking at this point is moving on to just practice a few problems and go from there. Okay, make sure we pause here and take time to practice these problems, solving for y, using that to help graph, and then find those intersection points. All right, good luck. Okay, so again, kind of putting them in your calculator, that should help us get these graphs as well. And we can see that all of these look like they end up being pretty good. Now, this one down here in the bottom left, that one's a kind of tough graph to kind of 100% guarantee that 4, 3. But using our calculator to plug those two equations in and making sure we're doing our calc intersect, that should help us find all of these answers with relative ease. Again, just making sure that we solve for y before we let the calculator do the help. Okay, let's take a look at the other 4. All right, so again, when we are trying to determine the solutions, we need to plug that 5, negative 8 into both equations, and they both need to be true. First one, neither of them are true, so that's a no solution. And the second one, we plug them in, that is going to tell us that is a solution. That is going to be where these two lines intersect. Okay, when we look down here, like we said, make sure you solve for y in both of these. Once we have those two equations, let your calculator help you out. Negative 8, negative 8. And then we start looking at this one here where we see negative 3x minus 7/3 and negative 3x plus 4. When you plug that in your calculator, it's going to cause some error when you try to do your calc. Well, think about why that is. We have the same slope. This is going to tell us that these are parallel lines and they will never intersect. So there will be no solution for that one. All right, make sure you finish up your work in Canvas. Good luck. Have a nice day.